Goodbye.
Hello. 5-3. Inverse functions. Okay, I'm going to explain this inverse functions to you this way.
Okay.
An inverse function undoes another function.
These colors are ugly. Don't I do
Okay.
it?
Shh. An inverse function undoes another function. Okay, so, like, let's say I start with y equals x plus 3, and I'm adding 3 to something, okay? What would be the opposite or the inverse that would undo that?
Minus.
Yeah, so y equals x minus 3 would undo that. Those two undo one another, okay? Now, I'm going to give you a real-life example. I don't ever like using my phone as a calculator, but if I have nothing else, it's like I have nothing else. So I have to use my phone as a calculator. So this weekend, I was helping my husband. He was reading me off numbers, and he was trying to figure out how much money he's made shearing sheep this year. Because he shears sheep over the weekends, like just about every weekend from
Did you have to restart?
Middle of October to middle of March. Okay, so here's what happened. So he was reading me off numbers, and I'm just going to throw out some numbers. So let's say it was like 196.25, right? Okay, added to, I need another marker.
Plus 247. Plus 1.
Okay, so you don't have to write this down, but I'm just going to write this down. 196.25, and then he'd say add that to 87.5, and add that to 49.6. And the problem would be I would get all these slew of numbers, right? And he would give me all those numbers, and I'd have more than 3. I would have like 15 numbers typed in. And the problem is if you type a number in wrong, you're SOL and you have to restart, right? Like that's the problem with the calculator, okay?
On your phone.
Unless you know the tricks, right? So I got all the way through, and there was a bunch of numbers that I was adding together, right? And he said 49.6. And what do? But I forget the decimal, so I add in there 496 instead of 49.6, and I'm like, oh my God. And my husband's like, are you kidding me? Just wait. My husband's like, are you kidding me? We have to restart. I said, no, just wait. I will fix this.
I'm a math teacher.
I'm a math teacher. I will fix this. So I added 496 when I did not want to. So what I can do is I can do the inverse of that. That's what inverse is. I could subtract 496, and then I'm back starting over, and I can add 49.6 and be hunky-dory again, right? Does that make sense? So I do the inverse operation, and then I'm back to where I started from, and then I don't have to redo everything again. He's like, oh, okay, that's fine. And then he was like not pissed at me, you know, like he was like, okay, we're fine, we can keep going.
Somebody left us in your room.
Okay, so inverses help out immensely. Inverse operations, huge, okay? So, an inverse operation, when you have an ordered pair, here are my ordered pairs.
Am I on the wrong side?
Shh.
Oh, no.
If you have an ordered pair, like let's say set A, how many ordered pairs are in set A?
3.
3. 1, 2, 3. Okay? If I want to find the inverse of those ordered pairs, I do this. What do? You flip them around. So X and then Y becomes Y and then X. That's how you flip them around. That's the inverse of them, yeah? That's how you invert them, okay? So, here you go. Here are my points, 1, -2, 2, 5, 4, -1. I'm going to put them in this table right here. I don't know why I gave you 4 slots instead of 3, but whatever. You'll have 1 slot that you don't use, okay? So there are my points, all right? If I want to do the inverse then, this way. What?
You just flip
You
them.
literally like write the points down. They're on your paper.
So then it'd be -2, 1.
So then it would be -2, 1. I'm going to do that in a different color. -2, 1. Okay. 5, 2. And -1, 4. And we'll see what this does to the graph, okay? So we were graphing a triangle. That's what we were graphing, okay? So I'm going to graph the first one in a different color. And we'll do it this way. 1, -2. 2, 5. And 4, -1. Plot those real quick and connect them. You'll have a triangle like this. It kind of looks like a right triangle, maybe.
No.
A little bit. You don't think that's a right angle on the right side?
Well, maybe.
Okay, whatever.
Okay.
All right. Whatever. Okay, so the second one. If I graph that in a different color, -2, 1, 5, 2, and -1, 4. Here he is. I bet that's a right triangle. You guys don't know what you're talking about. I bet this is a right angle. Right? You don't think that's a right angle?
No.
And this is a right angle? Whatever. Okay.
Whoa!
All right, so there's that. Now, whoa. Okay. It says describe the graph of the inverse. Describe that graph. Okay. It kind of looks like there's a little bit of a pattern to this.
Greg,
Right?
I'm gonna beat you.
Are we gonna find
the
a little bit of a pattern?
translation of that?
Kind of. Okay.
Except on my foot.
Okay. So
That'd be really
looking at
fun.
the pattern,
My
between that,
marker's
listen to this really
dead.
carefully because this will be the same for every inverse function. Okay. If I draw, do this real quick. If I draw this dotted line right here,
Yeah.
okay, it's a 45-degree angle dotted line.
If it goes through both of
Okay,
them,
just
then
wait.
you
No.
win.
If I draw that dotted line, okay, and if I like put this up and down like this, like that's my line that I put a mirror around. If I put a mirror down that dotted line, he's reflected on either side. You see how that works?
Yeah. No.
Yeah, like that.
That
Okay.
means you win.
That dotted line, okay? The equation of that dotted line is y equals
X.
x.
We win.
Y equals x is the equation of that dotted line, yeah?
Yeah.
Okay? So every single time, no matter what, if I'm doing an ordered pair, if I'm doing a function or something down below, they will always, when I graph them, always look like they're reflected across that imaginary dotted line. And the equation of that dotted line is y equals x. Okay, we'll do another example and I'll show you. It looks like it's reflected across that dotted line. So if I move him, if I put that dotted line straight up and down, he should look the same on both sides, yeah?
Oh, well, now it does.
Mm-hmm.
I thought you were talking about, like, if you, like, held your paper like
That
this. I
is
was like,
fun.
I don't know what.
So if you put that dotted line straight up and down, it's the same on both sides, right?
That's-
Same on both sides. That's and it will always be. It's always that line. Y equals x. Always that line. That he's the same around. Okay. All right. Now this was when you had an ordered pair. Okay. Ordered pairs mean x comma y. But
Shut up.
when you have an equation like this guy, you have to do something different. Okay. And it's not too much harder, right?
Plug in
2x minus 5. Nope. What you do is these steps right here. Okay, these 4 steps are what you're going to do every single time. When you have an
Are you
equation,
making it
just wait.
perpendicular?
Nope. Not quite. So finding the steps. Here are the steps. We're going to do the steps to this function. So the first step is change f of x to y. My little box, I ran out of room. Sorry. Change f of x to y. Okay, so step number 1. What does that look like here for this problem?
So you just have to
Y equals.
You betcha. Y equals 2x minus 5. That's easy enough, right? Step number 2 is just as easy. Switch x and y. So the x becomes a y and the y becomes an x. Okay, so step 2, x equals 2y minus 5. That's what step number 2 looks like. Oh, these 2 steps are so easy to start with, right?
Yeah, now they get
Okay,
hard.
no, it's not too much harder. The third step is the hardest of the 3, or of the 4, I guess. The third step, you have to solve for the y variable. So I'm solving for y, okay? So I'm just getting y by itself, and I'm rearranging this equation that I have in step 2 to solve for y.
I did not say you
Okay.
had to shove it in.
Okay. You're right. So I just add the 5. So plus 5, okay? So in step number 3, I have, how do I add 5 to x?
X plus 5.
X plus 5, right? Equals 2y. Okay? Now, I'm not quite done yet.
By 2.
I'm going to divide the 2, but I have to do it for all 3 pieces. Divide by 2, divide by 2, divide by 2. Okay? Now, just wait a second. I have y by itself over here. Okay? What is x over 2? What does that mean?
It's an L.
X times that.
Oh!
That's if x is in the bottom. What? What is x over 2?
It's not good.
Yeah, I like to write it as 1/2 x. I shove the x off to the side, right? X over 2 is the same thing as 1/2 x. Yeah, I like to write it like that.
Over 2.
And then plus 5 over 2. Okay? That's step number 3. Y is solved for, right? Some of you might like to write it opposite, so y equals 1/2 x plus 5 over 2. Okay? I like to do that as well, right? Okay, so that was step number 3, and then step number 4 is the last one. Okay? And all I do is change y to, and this is called f inverse of x, but it looks like f to the negative 1 power. That means f inverse of x, okay? Not f of x, f inverse of x. It looks like the negative 1 power, okay? So all I'm doing is renaming him, right? So the y becomes f inverse of x equals 1/2 x plus 5 over 2, okay? And now I'm going to graph my 2 guys. So I'm going to start with the beginning one. 2x minus 5. How do you start graphing that thing?
Go up to 5. Down to 5.
Down to negative 5. Okay, and then I go
Up 2 over
up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, you will probably have some questions like that where you have to graph these guys or whatever on your maps test. Can you do those tomorrow? Maps test tomorrow is math. It's math.
Ew.
Eat your Wheaties. I will be checking on your scores. Try to improve as best
I
you
went
can.
down 7 today.
Okay.
I went
up
not
one.
Go up
not
7
you,
tomorrow.
'cause it's
I went
math.
up
You
one.
were like,
Or down.
I
A lot of
went
people
up
went
one
down.
paper, and then it's just another.
A lot of people went down today.
Mhm. I had a lot of people go down too.
Wait.
Question,
Question. Do you have
one.
to retake it if you go down?
Yes.
No.
I don't know. I don't know.
No,
what
I
that
have
is.
to
If
retake
you're
it.
no, if you're still in your range for your year, he said you didn't have to take it.
Okay.
Really?
Anyway, just do
I'm
well
not
tomorrow.
good.
Eat your Wheaties. Do as best you can. I want to see your scores go up.
Just so you know,
Okay.
I'm shooting for a 250 something tomorrow.
That's yes. You
I
should.
mean, I already got a
You should.
251.
You should. You should. 254. 254. Okay. All right. Now let's grab the
Pretty sure
second
that's
one.
what I said my goal was.
Let's grab the second one. We're still videotaping. Grab the second one. Where do you start the second one at? Where is 5 over 2? What is that? Now, what is 5 over 2 as a decimal?
5 over 2 is the same thing as 2.
What
2.5.
are you doing?
Okay. So 5 over 2, let's make it a decimal. Let's start at 2.5. Okay, so I'm going to put a dot at 2.5. And then from that dot at 2.5, from that dot at 2.5, you go up 1 and over 2. So I'm still going to be at like the half mark. Do you see that? Up 1 over 2, up 1 over 2. Okay, I'm still kind of at the half mark. Down 1 over 2. Down 1 over 2, down 1 over 2. So all my markings are going to be like on the halves. You see that?
Yes.
Okay. All right, so there he is.
No,
Oh, buddy. Let me get my...
They don't cross
let me-
out.
Oh, they cross.
They don't cross out a nice number.
Oh, man. Look at this. Okay, that imaginary dotted line right here. You see that imaginary dotted line? If I make him up and down, is it the same on both sides?
No.
If I make him up and down?
Nope.
You should be.
Yeah.
Is it the same on both sides? Is he mirrored on both sides of that dotted line if I make him up and down? Sure he is, okay? What's the equation of that dotted line again?
F of negative 1.
Nope,
Y
nope.
equals
Oh.
X.
Y equals X is that dotted line. Okay, that he's flipped over. Y equals X. Y equals X.
Ew, we have more on this.
Okay. So now, they do one that's a little bit harder, right? Okay. X squared plus 1 is what we're starting with now. Let's graph him to start with. So I'm going to put him in red, or my magenta color. What does X squared look like? Just X squared. You
A
can graph him.
parabola.
It's a parabola,
And
what
it's
is-
up 1.
and it's up 1. Okay, so parabola up 1 is what he's doing. So he looks like this. He's going to do one of those. Okay, that's what my parabola is going to look like to start with. Okay, we know all those shortcuts. The plus 1 moves an up 1, so we don't have to plug in points. That's really nice. Okay, we know all those shortcuts. So now we want to do the 5 steps to him. So the first
So
step,
Y equals
y equals X squared plus 1. Okay, second step.
X equals Y squared plus 1.
Okay, now I will give you a little hint. My trig kids, or even you guys can probably do this, they like to skip the first and the second step, right? Because can you switch them, switch it to Y and then
Yeah.
switch to X and Y at the same time? So a lot of people skip the first step. Does that make sense? And they just go straight to the second one. That's fine, okay? Step number 3, I want to solve for Y. So what are you going to move
X
first?
minus 1 equals Y squared.
We're going to subtract the 1, so X minus 1 equals Y squared. Got it.
And square root.
Okay, now I want to get the Y by itself, and I have Y squared.
Square root.
Okay, and so then we think what undoes the Y squared? It is the square root. So I'm going to square root.
How do you do that?
How do you do that? So I have Y equals the square root of X minus 1. Can I do that? Can I flip the Y around? So I put the Y on the right side?
Yes.
So how are you supposed to
Okay,
graph
now
that?
just wait a second. Just wait a second. Just wait a second. We know what that graph looks like. There's one other thing that I'm missing inside of that thing.
Oh, it's a little, it's just this
Just
one.
wait. Yeah. Wait. So we're missing something. We put the square root in there, and whenever we put the square
Plus
root in, we
minus.
need plus minus, okay? So I need a plus and a minus in front of there. So don't forget that when we put a square root in, all right?
So
Plus
does
minus.
that
Okay, so now,
make
just
it
wait.
go both ways?
Yes. Well, kind of. I'll
So
show
it'd
you.
be like
Okay.
X. the
Just wait.
cube- cube
So
root.
y equals the square root of, nope.
Wait.
Y equals the square root of x. What
It's
does he
just
look
a
like?
ray.
Okay, you got to remember him. He's just a ray. He goes like this, okay?
He goes near like that.
Okay,
But
but,
the cubic root goes the other way.
yes, right. Plus minus, what does the plus minus do to him?
Nothing.
Yes.
It makes them go the other way.
And not the other way.
No,
it makes him
him
go.
the other one. Yes.
So now he looks like a parabola, but on his side. The plus and minus makes him look like a parabola on his side.
So you're gonna start
Okay,
at
so there's that.
-1.
Now, x minus 1. How does the minus 1 move him?
Oh wait, but
It's not down.
inside because it's inside, so it's to the right.
It's to the right one.
Well, I forgot about
Are we
that,
gonna
so mine
Are
just
we gonna
looks
get a
like-
sub? Like,
When?
when you have a kid?
No.
Like,
You don't want to
Just
say
kidding.
No, I do not.
Wait, so then what will happen?
I'm having this baby after school's up.
See, that's what I thought.
She's a planner.
I'm a planner. So to the right one. So we're going to start to the right one and put this guy right here. And then he looks like a parabola on his side, right? Okay. All right, now, here's my imaginary dotted line, which is y equals x.
Yay!
If I do that, is he the same on both sides? He looks a little wonky, but he is the same on both sides, right?
Yes.
If I do that, yes, it's so satisfying. On your homework assignment, when you're graphing these, I would encourage you to put the dotted line in there and see
Is that it?
if
Are
it's
we
the
done?
same thing, right? Oh, one more thing.
Dang it.
So well, let's go down to example 4. Let's go down to example 4, and you have one more thing. They give you F and they give you G, and they say, are those things inverses? Okay? F and G, are those things inverses of each other? Okay, now, here's the deal. What I'm going to do is to check this. You do F composed of G of X,
Ew.
and G composed of F of X. Okay? Just really fast. It doesn't take very long. Okay? So F composed of G of X means I'm
Yeah, but I don't get these.
Ah, okay, well, here's your chance to get them. F composed of G of X. G of X is what I'm sticking inside. So 1/3 X minus 3 is going inside of here. All right? So F was originally, the outside function was originally 3X plus 9, right?
But now you're gonna do
But now I'm going to put the 1/3 X minus 3 inside of it, right?
times
Okay. 1/3 X minus 3 goes in there. Do you see how that works? 3X plus 9. Yeah, 1/3 X minus 3. Okay, now, let's simplify. It's pretty short.
so you're gonna have to
What's 3 times 1/3?
3.
Nope. 3.
One.
What's 1/3 of 3?
1.
1. So this is 1x. What's 3 times 3? Negative 3.
-9.
Negative 9 plus 9 equals,
X.
right? The 9s are going to go away, so that answer is just x. Oh, boy.
No.
Okay, so let's go to the next one. G composed of f of x. All right, so f is the inside part. F was 3x plus 9. That's what I'm going to stick inside of G. Okay, G was originally 1/3 x minus 3, but the x is going to now become the f part.
But it's gonna
3x
be the
plus
same
9.
thing.
Oh, man. No, man.
No.
Okay,
No, it's
1/3 times 3
it's
is 1. 1/3 times 9. What's 1/3 of 9?
3.
3 minus 3. That comes out to be
It
x.
is.
Those two both come out to be x's.
Like I
Okay?
said.
And if, not if they come out to be the same thing, like, because if one comes out to be, like, let's say 7 and the other one comes out to be 7, right? It doesn't work unless they both come out to be x's. They must both be x's, like it says up here. Must both be x's and x's. Why x? Because what's the name of this line right here? Y equals x. So if both of those come out to be x, yes, they are inverses. You see how that works? Yes, they are inverses. Check. Because both sides came out to be x's, we are good to go. Okay, they have to both be x though. All right? So let's check the bottom one. Let's check part B and let's see if that one works. So we have to do f composed of g of x, and we have to do g composed of f of
I'm
x.
gonna say it's not.
You think it's going to be a no?
I-
Right? Because why would they
the
give you
other
two yeses,
Yeah.
right? Okay, so let's see. So G, what we're sticking inside is 2 square roots of x, right? Okay, F is the outside. So 4x squared was what it was to start with, right?
one- Wouldn't the square root
So
just
Okay,
go away?
so just wait. So I have 2 square roots of x goes in the inside, yeah?
So wouldn't
Okay.
the square root just go away?
Yes. Okay, so really this 2, though, gets distributed for both of those pieces,
So
okay?
she's 4x.
So 4, and then I have 4, 2 squared is 4, and the square root of x squared is just x, right? It just makes the square root go away, so it's just that, right? And what does that make?
16x.
That makes 16x. Ooh. That's not the same thing as just x, right? 16x isn't the same thing.
Yeah. So it's already just no.
So it's already a no. I don't even have to check this side because it's already a no, not inverses. Does that make sense? They are not inverses of each other. If one fails, don't even need to check the second one, right? Okay? So it's less work. Does that make sense? Okay, so let's go back through here. Hold on just a second.
Wow.
I'm going to go back through. If you're given ordered pairs, what do you do to find the inverse?
You have to flip
You just flip them, right? If you are given an equation, you have to
graph it, and then solve.
you have to graph it and do the 4 steps, right? Okay? And then if they give you 2 functions and say, are these inverses?
Then you have to do
Fog.
Plug them into each other. Goff and fog, right? Okay, there you go.
Bye.